I'm going to show a quick tip which can help you to avoid crashes of the machine tool when starting a 5-axis toolpath. Now this problem often occurs on machines which do not invoke the RTCP tool center tip control until the tool reaches the start of the toolpath. So if I just put the tool vertical for a moment, now I'm just going to switch on this machine tool and activate the standard toolpath. This is a toolpath created by default. And you will see that the tool is being inclined at 90 degrees to the machine tool's Z-axis. So when I simulate from the start, immediately the A-axis rotates to approximately 90 degrees. Now the problem with that is there's the RTCP tool center control is not switched on until it reaches that position and has the potential to cause a crash. Now if we just go back to our HTML window, and what I'm going to do is just open up this document to show you the actual G-code that's produced from this. So here we have the G-code on the left where we've got A0, C0, and then immediately we jump to A-90, C83. And only after this move is RTCP switched on, so it can be quite a dangerous move to make. So we're going to look at an alternative, perhaps safer method. If I go to the start and end points form, you can see that I have this option to overwrite toolaxis. And if I switch that on, I can change the vector of the initial toolaxis at the start point of the toolpath. Now I want it to be aligned with the positive y-axis on the currently active work plane. So the y-axis happens to be the machine z-axis. So if I just activate this second toolpath, you can see that I've overwritten the tool axis and I've changed it to the y-axis 0, 1, 0. What happens now when I simulate from the start is the machine tool starts at A0, C0, which is exactly what I want. So we've had none of the rotary axis moving as we approach the start of the toolpath. Then when we start cutting, RTCP will be switched on, so the tooltip will safely traverse along the bottom of these plunge moves outside of the part until it's fully rotated, and then it will enter the part. So it will rotate and then go back in. Let's just do that a little more slowly. So as we come down, it will rotate and then move in very safely and then exit again and rotate back along the vertical line. Now if we again just take a look at that output from that, so we'll click that button again. Here we see the document. So if we post-process this file, we start with A0, C0, but then we have a linearized move, the C-axis moving very gradually. It's quite different. I've removed some of these C-axis just for clarity until we hit the part, and then we start moving in X, Y and Z. So this can be a much safer method of machining this part. So if you read the information on the HTML, you can see that some controllers do not require this, such as Heidenhain or Siemens. But with Siemens it can depend on how the machine builder has set up the controller. And we've certainly had this problem with Matsuras in the past. So when working with machines like a Matsura, you're best to override the tool axis and put a safe tool axis at the beginning and the end of the toolpath.